But if a craft left our galaxy to visit these new worlds, its mission would be tough, thanks to the physics of the cosmos.
From our perspective here in the Milky Way, every galaxy is on average receding away from us. It looks like nobody likes us and is trying to get as far away from us as possible.
This is because our giant universe is expanding.
When we talk about the expanding universe, we don't mean that galaxies are doing something active to run away from one another. Actually, it's the underlying space that's expanding, and the galaxies are embedded in that, and that's what causes everything to move apart from everything else.
The regions of the universe within 3 million light years of us are expanding at around 45 miles per second, over 160,000 miles per hour.
So with our current technology, do we have any chance of actually seeing what these other planets are like? Well, think about the fastest and farthest things we have right now, like the Voyager spacecraft. They've been in space for more than 30 years, going incredibly fast, 38,000 miles an hour.
38,000 miles an hour is fast. But the closest galaxies to us are moving away over 4 times faster. And the further away a probe is sent to travel, the tougher its task.
The thing about the expansion of the universe is that the farther away something is, the faster it's moving away from you.
The more distant two objects are away from each other, the more space there is between them. And the more space there is between them, the more space there is to expand.
The rate at which they're moving away is proportional to their distance. If it's twice as far away, it moves away twice as fast. If it's 3 times farther away, it moves away 3 times as fast.
Scale it up to the planets we've discovered 3.8 billion light years away. And thanks to the expansion of the universe, those extragalactic worlds are moving away from us at over 49,000 miles per second.
Imagine that you're a runner and you see the finish line. You're getting a bit closer to it. But now actually the track itself is expanding. And as the track expands faster and faster, it's expanding faster than you can possibly run. All of a sudden that finish line starts receding and you're never, ever gonna reach it.
Say one day we're able to build probes that travel at the fastest speed physics allows, the speed of light. Even that might not be enough, because sometimes the universe itself doesn't play by the rules.
It's not possible for things to travel through space faster than the speed of light, but it is possible for space to expand faster than the speed of light.
Everywhere we look, we see very distant galaxies that are apparently receding or moving away from Earth at greater than the speed of light.
There are distant galaxies we can see in the sky that even if we were to build the most advanced spaceship possible that could even move at the speed of light, we could never get there. 97% of the galaxies that we can see in the distant sky are actually unreachable to us.
For all the galaxies out there and all the planets that could harbor life, most of them are out of our reach. The physics of the universe has dealt an immense blow to first contact.
The true reality of the universe will always be hidden from us because of this expansion.
The further we look out into the universe, the more unlikely first contact becomes. We might need an advanced alien race to come and visit us instead. Suppose we get that lucky. Even then, would first contact actually be feasible?
We think aliens are like us. They're not. We're assuming that the life is like us and that their planetary environment is like ours. I don't think that's going to be the case for most of the life in the universe.
Could extraterrestrials even survive first contact with us and our planet? July 2019. The TESS satellite discovered a new alien world 31 light years from us, named GJ357d. At over 6 times the mass of our home planet, it's thought to be a super-Earth, And from our observations, super-Earths appear to be prime real estate.
What we see is that the most common type of terrestrial planet is what we call a super-Earth. So that means it's a terrestrial planet, but much more massive.
More massive means more gravity, creating a planetary environment completely unlike our own. And life completely unlike ours.
If they're on the surface of a super-Earth, it could be that gravity is going to be way stronger. So these aliens aren't going to be very tall, but they are going to be very strong.
Super-Earths are just one of many avenues the universe creates. There are other exoplanets orbiting red stars, 10 times smaller than our sun, and others making binary systems, comprising 2 stars instead of 1.
We see planets of all shapes and sizes around stars of all shapes and sizes of all sorts of configurations. The potential for life is much more rich and varied than we ever thought before.
Retro rockets, 5 and 6, fire.
Images of science fiction have fueled numerous fantasies of first contact, but our knowledge of the universe suggests reality could be far, far stranger.
If anything, Hollywood has kind of constrained our imagination in terms of presenting so many aliens that basically look like, you know, humans wearing a rubber suit or something.
Lower landing legs.
We have to let go of this obsession that they're going to be anything like us. So if we're looking for 2-legged dudes, forget it.
Say an intelligent alien species lives in our stellar neighborhood and wants to make first contact. If that alien evolved on a super-Earth or orbited a red star instead of a yellow one, its wildly different biology may prevent it from ever setting foot or tentacle on planet Earth.
When you look at life here on Earth, it's almost as if it was custom made for this temperature, for these elements, for this environment. An exoplanet with conditions to support life could still be completely different than life here on Earth.
What are things going to be like on an alien world which has a little bit more potassium, or is warmer than average on Earth, or has a thicker atmosphere? Each one of these small variations can mean a completely different ecosystem.
So could an alien organism really adapt to our ecosystem when it lands on Earth? Maybe we haven't made first contact because they can't actually visit us.
They could step through the airlock of their spaceship and onto the Earth and just find something toxic with our environment, some reason they're not compatible with the surface of the Earth. It's almost as if the universe is out there deliberately trying to stop us meeting any aliens.
Biology creates another obstacle for making first contact. But as planetary scientist Janie Radabaugh finds, even life on Earth can get really weird, taking extreme measures to adapt to a potentially hostile environment.
This is the Great Salt Lake. It is the remains of what used to be a much larger lake in the past, and when it evaporated away, it left behind all of the salt.
The Great Salt Lake is nearly 10 times saltier than the Earth's oceans. The extreme salt content should make it an inhospitable place for life. Despite this, there are organisms thriving in the water.
As we look at life in this vast lake and find that there are billions of microbes living here in this unexpected environment, then we start to realize, well, life forms in ways that we just don't expect, in places we don't expect.
Microbial life, known as extremophiles, have developed an ingenious way to survive in the lake.
They actually use these solar-powered pumps to pull the salt out of their cells so that they can operate more normally. But in order to do that, they have to live very close to the surface, which means they get a huge amount of UV radiation. So all this pink color that you see behind me is actually the pink of the organisms, and it's sort of like a built-in sunscreen that helps protect them against the UV radiation.
Extremophiles are rewriting our expectations on where life can survive on Earth. Could alien biology be much more resilient than we think?
These extremophiles should be a little reminder that we haven't been thinking big enough.
Maybe ET could readily adapt to our environment. Or perhaps they've got other ideas, using technology to overcome any biological barriers.
Maybe the first aliens we meet will be robots.
They can build much more powerful life if they don't limit themselves to meat bags.
Advanced aliens could have left their biological brains and bodies behind, traveling instead as mobile artificial intelligence.
We tend to think of intelligence and consciousness as something mysterious that can only exist inside of biological organisms like us, and somehow therefore can't be copied. But what's given us the whole AI revolution, right? The idea that no, intelligence and probably consciousness too is just information processing, and it's just the information processing that really matters.
Perhaps an alien would be able to download its consciousness into some sort of computer and travel as a disembodied consciousness. In this state, you'd be essentially immortal.
Even if robotic probes are heading for Earth, there's another barrier awaiting us: language.
If we do make contact with aliens, are we going to be able to understand each other? Can we communicate?
There are around 7,000 languages spoken around the world, each with different sounds and structures. And on top of that, there are other species entirely.
I think one of the things that should make us very humble when it comes to communicating with other civilizations is just how much trouble we have communicating with other intelligences on our planet, intelligent animals.
Now imagine how much harder it would be to communicate with a life form that's come from a completely different planetary environment.
If I were to base my perspective just on movies, I would think that interspecies communication would be easy and frequent and often. But that's not the reality.
Science fiction movies will always take shortcuts, that whether it's traveling faster than the speed of light or cheap and easy and instantaneous communication between races. You know, you put something in your ear and suddenly you have a universal translator. The real world would not be that easy.
If we were to try to speak English or Spanish or Italian to an alien civilization, those languages are far too steeped in our local history on Earth to be even remotely recognizable or decipherable to an alien civilization.
Overcoming the language barrier between humanity and an intelligent alien race may require us to take some baby steps.
We have intelligent creatures on Earth. They may not be advanced technologically, if you want to use that phrase. They live in the water, you know, whales, dolphins, they're very intelligent, social animals. They communicate with each other.
We have the gorilla, Coco, that was communicated with using hand symbols. We use our own human speech to talk to our dogs and they respond. We have these birds that can mimic our human speech. So I think everything is on the table.
Hello. Hello.
Perhaps we can practice on how to communicate with aliens by communicating with different species here on Earth.